Hey there, today we're going to take a look at how to make a box and whisker plot. First off, what is a box and whisker plot? Well, a box and whisker plot is simply a diagram used to display the variability of data. What that means, in less fancy words, is it shows us how spread out our data is. It shows us how spread out a group of numbers are, which can be really helpful when you're dealing with large volumes of numbers. These types of plots are used very regularly when working with the stock market. Many graphs that you'll see of stocks will make a box and whisker plot for every single day that the stock has been open. But here's what we have going on. First off, we've got the minimum and the maximum. We've got our whiskers here on the ends, and that's where our minimum and our maximum go. Somewhere in the middle, we're going to have our median. As we know, this is our middle number when we arrange all of our numbers from smallest to biggest. It may not necessarily be directly in the center of the minimum and maximum, but it will be between them somewhere. We also have this Q1 and this Q3. This stands for the first quartile and the third quartile. And I'm going to tell you how to calculate those, right now. Okay, so when we're calculating the first and the third quartiles, what we actually have to do is first find the median. We need to find the median of our data set because we're going to split things up with that median. So if we cross things out, we would cross out the 1 and the 9, the 2 and the 5, and then the 3 and the 5 here. So we'd be left with the 3 and the 4 in the middle here. So the median is 3 plus 4 divided by 2. Because as you remember, if we have two numbers in the center, we have to add them together and then divide by 2. So the median is going to be 3.5. Well, to calculate the first and the third quartile, we need to take all of the other numbers and split it up. So basically, we're going to take the lower half for the first quartile, we're going to take the upper half for the second quartile. However, we also have to leave out the two median numbers. We have to leave out this 3 and the 4. So the first quartile is going to use 1, 2, and 3. And we would simply find the median here, which would be the middle number, which is 2. So our first quartile is equal to 2. And we would do the same type of thing for the third quartile, except we would use the top 3 numbers. So we see that 5 is our middle number here, so our third quartile is 5. Like that. So we're going to take this information along with our median here, and on the next slide, we are going to actually draw out a box and whisker plot for this. Okay, so let's write down the important information that we had from the last slide. Our median is 3.5. Our first quartile was 2, and our third quartile was 5. Now we also need the minimum and the maximum. Well, the minimum is 1, and the maximum is 9, simply because they're the smallest and the biggest numbers. All right. So first thing I need to do is I need to make a number line that needs to have more numbers than we have up here. So 1 is my smallest, so I'm going to start this out at 0. I go 0 through 12 here. So I'm going to draw out my stem and leaf plot, box and whisker plot. I've been known to mix those up in the past. I'm going to draw my box and whisker plot right above this here, with all of my important information. So first off, my minimum is at 1 and my maximum is at 9. So I'm going to draw a vertical line at 1, vertical line at 9. So we connect them like we see there. Our median is at 3.5, so that's going to be in between 3 and 4. So we have our median right here, and then our first quartile is at 2. And our third quartile is at 5. So here we've drawn out our box and whisker plot, and what this actually means is most of our points are concentrated down around the bottom here. We've got one or a couple of points, depending on our data set, up higher, and that's what this far out whisker indicates. It means that there are some that are up higher, but since our first and third quartile are lower down with our median, it means that most of our data is concentrated down low.